got a definitive list using the course. Well, I think it's definitive now. About 115 people, I think, this course. I'm going to circulate two, they're identical, the course list. I'll circulate one round this side of the room, one round this side of the room. Just put your initial, they're in alphabetical order. You should be able to find yourself fast. Okay. So, can everybody make sure that they do sign one of the folders? I am going to be quite hard about attendance this year, harder than we were last year. There's not much more else to say. The sections are now worked out again. If anybody's got any questions about which section they're in, they're worked out. We shifted the location for Amanda's section from the small room on the 12th floor to room 1206. It's a larger room. So those of you who were in Amanda's section, I think she's already sent you an email, but you're in 1206 now. Aside from that, I think in terms of like housekeeping technicalities, that's sort of where we are. Assessment and so on for this course will gradually come in. We're not going to do it immediately in terms of projects. Let's sort of we've all got projects for other classes and things. Start that probably next week more. And now it just means I can do a little introduction to Sven. Travis, some of you will have already met Sven. Already know Sven. But just for those of you who are not in design and technology, Sven was really the founder of design and technology and the founder of the MFA program in design and technology back in, when did it start?
97.
So it's had a long history and a kind of shift in history and a kind of pioneering history, and it's largely down to Sven's single-minded entrepreneurial and intellectual efforts that this field is constituted in Parsons Hackle, which is almost entirely for him. So plank should be there. And this course, as I said last week, comes out of Sven and I's conversations about taking further, beginning to think the fields of design and technology and their interaction, their interrelationship, and gradually beginning to kind of comprehend the coming together, which is actually happening objectively, I think, of these two fields. This is going to be really what we're going to be looking at the next 2 or 3 weeks. The fact that we can't actually have a field called technology anymore, and perhaps can't have a field called design anymore. That the interface is not design and technology. That appears to be two things that you kind of force together. It's more like they're actually intertwined in complex ways. And our thinking is really how they're intertwined, to figure it out. It's already happening. It's happening in a sense, in some cases, I think, below thought. We haven't yet got it. So, with no more ado, Sven.
I'm really horrible at timing these things, so this lecture could last anywhere from 11 minutes to 4.5 hours. But I will cut it off at the point where you need to go to the next class. I've said this before, but there are a lot of us here still getting used to these schedule changes for forever, for decades. It was always 9, 12, 3, 6, and now there are these little shifts. I believe this lecture officially starts at 12:10 and ends at 1:30. The recitations then start at 1:50 and go until, help me here, 3:50? 2:55. Okay, thank you. I'm still trying to get a grasp on this. What it does mean is, please, even if you're in a class prior to this, they should be letting you out in time to get here and be seated by 12:10. Now, in my case, you haven't or wouldn't have missed anything. You'll realize that as I start talking. But in most instances, you don't want to miss the first 5 minutes of the lecture. And you know, yell at your faculty beforehand if they're not letting you out in time. The first thing I wanted to note that I don't have a slide for, well, I want to apologize for the fact that I discovered about 10 minutes ago that I'd actually been preparing this lecture in 2 separate keynote files. I did not know this. So I have no idea what you're about to see. I think I've got the right one. But what I didn't catch, because I was just writing it up here, is that Friday night there's a great event over in Tishman Auditorium to celebrate the John Cage centenary, 100-year anniversary of his birth. I think it's primarily being put on by the Media Studies program, which you should all be aware of if you want. They're the biggest, actually they're the biggest grad program at the university. They reside in the New School for Public Engagement. And you'll find as you go forward that a lot of times courses and different types of events like the John Cage event on Friday are very, very relevant to you. Anyone who does not know who John Cage is or know of his relevance to really modern art and the modern world should definitely go. And those who do know will know why you should go. So it should be a lot of fun. There are going to be some performances. And I think it's simply open. You don't need a ticket for it. So I think it's Friday night. Tishman is the big auditorium, if you don't know this yet, right at the entrance to 66 West 12th Street. So I'm going to start with this slide and kind of ease into my lecture today. This was an article that was actually pretty amazing. Got up, I always get up in the morning and read the New York Times. I'm kind of, I guess, pretty obsessed with it or addicted to it, is probably better. It's my sole use of my iPad is to use the New York Times, or to read the New York Times. And I guess it's worth it. I use it every day for that reason. But a study was just released that is unbelievable. A massive scientific study on the purpose of the junk genes within our body. Forever, scientists have been saying, you know, the human genome has only a very small percentage of relevant genes. All the rest is just junk. You know, we don't know what it does, but it's all junk. And what they've discovered is that it does a lot, and it's not junk. And in fact, it is this supposed junk genes that is determining whether we live or die, how big we are, how much we grow, our resistance to certain diseases and stuff. And so many of these previously thought of as junk genes are triggers, and they're triggering the relevant genes to act in particular ways. The way the scientists were describing this study, most of you are well aware of the Human Genome Project that mapped the entire human genome. They're saying, okay, that was like looking at the Earth from outer space. This is like a Google roadmap, what has just come out, because they're looking so specifically at these trigger mechanisms. It was done by something like 400 scientists over 40 or 50 different institutions, so it's massive. It's a massive study. And take this reference and go read it, because the reason I start with it, and to a certain extent it's a follow-up to what Clive was saying, is that what technology means to us, regardless of what program we're in here, regardless of where we are in the world, is very, very different today than it was 10 or 15 years ago, when sometimes the kinds of questions I will ask today were a lot simpler to answer. You get students coming in because they were just fixated on learning how to program for the web, and that was a perfectly reasonable goal, and they could get a job going out and doing it. They still can. But, you know, questions like this isn't a question, but topics like this were rarely brought up. We were much narrower in our focus, and I think Clive is right on that the times they have changed. They are still changing. And this really is the gist of my lecture today, is what is our relationship with technology? On a personal level, what is your interest? You know, you'll have some practical reasons for pursuing graduate work, for pursuing your practice on an everyday basis, but really what I want to dig into is the deeper issues, the deeper connections, and how you're viewing the world around you. And I want to start not by talking about any of the readings, and you'll see here in the slides that I show, I actually spend a little more time talking about the writers than the actual readings. I would hope that in your recitation sections you get a chance to discuss some of what I put forth. I know I threw out a large quantity of reading, and you won't all have absorbed it all, but first, I want to talk about Herbert Simon, because this is a book, and I've said this to my recitation already, but The Sciences of the Artificial, that if you don't buy anything else for this class, you need to go out and buy. And you need to read it, but what I want to talk about here is the broader impact of Herbert Simon on fields beyond design theory, etc. And what's interesting for me about Herbert Simon is that when I first was introduced to him, it had nothing to do with the topic of a class like this. It had nothing to do with design. This is Herbert Simon, younger than I am, I guess. You know, sitting in front of a chessboard in some lab at Carnegie Mellon, where he spent virtually his entire career. And for those of you who know Carnegie Mellon as an elite university, I can say without hesitation that one of the reasons it has the stature that it has today is because of the work of Herbert Simon. He was absolutely seminal in initiating so much of the activity at Carnegie Mellon in the realm of computer science, in the realm of economics, of systems theory, etc. Many areas beyond what we talk about in this course, but in a way overlapping what we talk about in this course. So, you know, the fact that he went in there and he was dealing with all of these things had a really fundamental influence on the institution that he was working at. So you should not separate Carnegie Mellon from Herbert Simon. You should look at Herbert Simon as a man who worked in all of these areas, and in fact, he's perhaps most famous for his work in computer science. And the book, Sciences of the Artificial, actually, as you begin to think about it, has a crossover very directly into this whole question of what does technology mean when we discuss the artificial. He won a Nobel Prize for economics, actually. Often a very different direction. And, you know, he's definitely a guy that you want to have in your repertoire. This is the book. I think the cover is still the same, we believe. And I believe it's still the 3rd edition, is that right? Yeah, so buy it, read it, you know, it will come in and out of these lectures. A lot of it will be during the first weeks as Clive touches upon the role of the artificial, but it is something that you will find yourself returning to again and again. Herbert Simon, there's a lot of information about him out there. I use this screenshot of Wikipedia just to make a very dumb comment, but I think most of you are very used to using Wikipedia. We all probably err a little too much in using Wikipedia, but Wikipedia is an amazing resource. And I'm not saying this to get you all to run out and open up Wikipedia. You've all done that. But I want you to remember, as you're working through on a variety of your topics, the way Wikipedia works is that it's not just about us looking up Herbert Simon and saying, oh, interesting, you know, he has a big Wikipedia page, he must be an important guy. It's the way you make all judgments. It's also about us contributing. And I would ask a broad question. How many people here have actively contributed to Wikipedia? A few. That's great. It's not enough. You guys are working on the graduate level in very, very relevant topics. As you do your research, as you go to Wikipedia, think of adding a paragraph here or there. Don't be afraid of this. The worst that can happen is some dopey editor comes in and removes what you just put up. You know, and if what you put up is relevant, they won't, because you're adding to, I won't say the literature, but the information. And it's a very interesting way of understanding not only how Wikipedia works, but joining broader communities of thought in particular areas. So that's why I brought up this page. Herbert Simon has a great autobiography out. It's a little nerdy. It's written by a computer scientist, engineer guy, Herbert Simon, but worth reading, and it's a great commentary on the nature of technology and the development of early computing, early artificial intelligence, a lot of the other work that he's done over the 50s, 60s, into the 70s. So if you get interested in the guy beyond the book you're reading for this class, definitely think about opening this up. Artificial intelligence, which is not exactly one of my favorite topics, but it's actually a topic that is very relevant to this conversation today because it crosses over into so much of our conversation when we're combining computation and digital aspects of the artificial. The history of artificial intelligence is really up and down. In the late 50s and 60s, it was a time that Simon really came up and moved to Carnegie Mellon, began to combine cognitive psychology and computation and wonder what could be done with it. Marvin Minsky working up at MIT, John McCarthy eventually out at Stanford. They had really high hopes. They were going to, remake the world using computers. The world has been remade using computers, but not quite in the way that they did it, or that they saw it. And, a lot of people, my father, when he was working, he's retired now, was an artificial intelligence researcher at the University of Wisconsin in Madison. And, the way he describes his career is as disappointing. Not his career, but the fact that far less progress was made with a lot of these activities than anyone would have hoped if you talked to people in the early 60s. The easy things turned out to be incredibly hard, and the hard things were easy. I think that's the best way to describe it. It was easy to get computers to solve mathematical problems. And in fact, this is some of the really seminal work that Herbert Simon did as a young researcher at Carnegie Mellon. It was incredibly difficult to work with these kind of areas. What really is happening in our consciousness, our brain, pattern recognition, vision. Something like 80 to 85% of human brain activity is geared at times around vision and pattern recognition. And this was something that proved very, very difficult to get going with computers.
What do you mean by vision?
What do I mean by vision? Looking out of the eyes. Vision. Why do you ask? I mean, what would I mean by vision?
You could interpret it as imagination.
No, I'm talking about literal vision. What happens when we see, how our brain processes it, how we recognize things within the visual field, etc. So these were incredibly difficult things, and there were decades where there was seemingly little progress in them. And so at the point where Herbert Simon died, which would have been in, pardon me, I'd go to Wikipedia and find out, maybe the mid-90s. It was about almost 20 years ago now. You couldn't say there was a lot of enthusiasm for artificial intelligence, but times once again have changed, and we are in the middle right now of an absolutely unbelievable energy flow of activity in this realm, and you need to be aware of that. You are able to do things with computers at this point in time that even 10 years ago we weren't dreaming of, but 25 or 30 years ago we weren't even thinking of. And it's important that you make that connection, that although the early predictors and prognosticators of artificial intelligence were way off, we have actually arrived at a point where some of the people, Ray Kurzweil being one of them that I talk about today, are actually closer to reality than sometimes is comfortable for us. So many of you know Zach Lieberman. How many are studying with Zach right now? That means your first year grads and all the classes were full when you came in. For people who don't know Zach, he's a professor in DT. He actually works a lot across DT and Trans-D. He's actually a graduate of the MFA DT program 10 years ago, I guess about now. And he's going on to great international fame. And the reason I bring him up right here is not only to say, hey, do whatever you can to get involved in projects. It doesn't always mean enrolling in a class. Zach spearheads a lot of different projects. And you'll see actually a couple of examples of projects that have been, very important experiences for grad students in these different programs. Zach is working in a way, he wouldn't admit this, but he's one of the more recent purveyors of artificial intelligence. And a lot of the work that he does with code, open frameworks, some of you will recognize the term, is really looking at these issues of pattern recognition and computer vision. And the reason I like to give the example here is that as we read these things, as we read these texts,